Hello, thank you, Alicia. Good afternoon, everybody. My name is Xiaoqian. This is my first time to Italy, so nice to meet you, everyone. Yeah, I'm a Pi system project manager from Keyman Technologies. This is my company located in China. It's an honor that Pimsoft gave me this opportunity to share a system project, which I will share with you today, named Sigmafine application in SP Chemicals Taixing plant. This is an interesting project because it is a real international collaboration between China and Italy. I mean, Keyman Technologies and Pimsoft. Okay, this is the contents I want to share. The first part, I will want to tell you the history of SP Chemicals and then Keyman Technologies. Later, I will introduce the project background and scope. Then I will share you with the process of implementing the project, including the difficulties we encountered. Finally, I will present the project results and conclusions. So let's begin our first part. SP Chemicals is our customers. SP Chemicals started in 1995. It produces petrochemicals including nitrobenzene, aniline, acetylene, and styrene monomer. It's one of the largest multi-site produced in China, producing more than 320,000 tons of styrene and 185,000 tons of nitrobenzene every year. SP Chemicals has many EU customer like Basfer, Dow, Jangsu Nobel Chemicals. SP Chemicals product line includes we mentioned before styrene monomer and chlorine and wiring chloride. The Sigmafine, our pilot project covers chlorine and wiring chloride processes. Okay, later is my company, Keyman Technologies. Keyman Technologies was founded in 2015. It's an official OSIsoft and Pimsoft partner in China. Locally, it has good relationship with several Chinese government departments. We are a young team, but our founder and the core team have rich experience in top international IT firms, came from top-notch colleagues, including Carnegie Mellon University, Dartmouth College, Georgia Tech, and Singapore Nanyang Technologies University. Yeah, our provides including PIMS, consolidation, Pi system installation and training, Pi system-based application and big data collaboration. We are dedicated to providing enterprise software, project consolidation, implementation, and service, and strive to merge IT and OT with the Pi system and other software and automation solutions. Okay. This is the third part of my presentation is project background and scope. Okay, so how did this project start? The story should begin in 2018. SP Chemicals have some troubles in terms of mass imbalance. Yeah, there are some gaps between their inputs and outputs. Keyman Technologies happen to know that Sigmafine is OSI-based product designed for data reconciliation. So we held a Pi user conference to introduce the Sigmafine to SP Chemicals. yeah, they become interested and then invited Pimsoft and Keyman Technologies for an on-site meeting to define the pilot project. Look at the background picture. Yeah, there are the characters in our history. Gambrelli and waiting now. Yeah, my boss. Okay, and the customer and me. Yeah, they are in the picture. Okay, but there are two challenges of our pilot project. One is one is because it's a national project. One is the language barriers for SP Chemicals to understand how Sigmafine works and what it can bring, solved with the help and Keyman takes local support. The second difficulty is balancing a complex petrochemicals facility in relationship with the standard scope of a pilot project, both for size and business need. Because pilot project standard is like this: scope, only one analysis, one model, duration 10 to 12 weeks, model size 100 elements, environment hosted or offline, deliverables include model, report, and presentation. But the ideal customer scope exists, the standard pilot project, scope multiple and analysis. For example, component multiple models, yeah, utilities upstream planes, duration, yeah, continuous, yeah, plane size, Taixing planes has more than 3,000 elements. Plant environment PI system connected to the Sigmafine, deliverables, models, reports production, inventory, loss, aggregation based on materials is it's very huge. Finally, we and the customer engineers simplified the production processes of the wine chloride and dichloroethane, and the process are regarded as the most important assets. Yeah, like this picture. It's clear that the main inputs are chlorine, yeah, ethylene, and oxygen, and the main products are wine chloride and dichloroethane. And last, we define the pilot project scope. One analysis, yeah, mass balancing, and 100 elements consisting of boundary inputs and outputs, as well as the boundary tanks. This is our pilot project scope. Next, I will share with you the project implementation. We divide our project into 7 parts: data collection, template alignment, and Sigmafine environment creation, build Sigmafine model validation, cases analysis, and results and conclusions. Through the timeline, and the bottom of this slides, we found the model validation and case analysis consumed 2/3 of our project duration. Yeah, in the last part, we will show you why they take a lot of the time. So the first stage is collecting data. Yeah, we collect data including PI data, external data collection, PFDs and P&ID, operating manual, meter tolerance, strength table, and UOMs. In this pilot project, the financial transfer, I mean external data collection. External collection is financial transfers. They are track loadings. Okay, we build the Sigmafine model based on all the information collected. Includes this information should be considered in our Sigmafine model: inputs, materials, and quantities, and outputs. Yeah, materials and quantities. Storage tanks, wastes, lost is flares, and recirculating flows. Yeah, finally, we build this Sigmafine model. It includes 20 inputs, 10 outputs, 17 storage tanks, waste includes gas and liquid, recycling flows. Because it's a pilot project, a pilot model, we keep it inside the Sigmafine object. The data source includes Pi system, streaming table, and financial data. Data we mentioned before, they are product transfers. When we zoom in the model, we can find the inputs includes chlorine, ethylene, and oxygen, and the outputs including burning, waste, wastewater, and some flares. Yeah, this is our Sigmafine pilot model. Yeah, this is my last part of my presentation. Is project results and conclusions. It's last but not least. There are two phases of our pilot project. Phase one, there are 14 tanks. There are no transfers and partial inputs and all outputs. But the imbalance was very, very huge. We discussed the gross areas with the customer, with the custom engineers. The customer checked the P and ID and found that it missed some important flows and important tanks. Then the missed tanks and transfers and flows were ended into our model, which was then used in phases 2. Yeah, this is phase 2. Sigmafine model now includes 17 tanks and 2 transfers and all inputs and outputs. But we also find some data quality issues in character unit of measures and pi tanks frozen, tank meter levels. Okay, there are two kinds in character unit of measures. There are two kinds including millimeter and percent for tank level measurements. Okay. And we encountered the pi tank with frozen measurement. Look at the picture. On this tank's meter level remain same during a long period. Then we align UM with every tank in the Sigmafine model, and instead of the tank's meter levels, we used the wet cell. With the wet cell, you can see the picture. It changes when the time changes. We use wet cell to wet the material's mass inside the tank on the tanks, which had unreliable level measurements. Okay, so we solve all the problems. Okay, phase 1, we detect gross. We review our project process. Phase 1, we detect gross errors. We discussed it with the customer. The initial imbalance is about 25%. Yeah, it's big. And phase 2, measurements data qualities. finally, the implant declined to about 8%. This is the starting point for engineering data analysis of slogan. Yeah. And just look at the graphic. We have two indicators. The first one, DX1. DX1 is imbalance indicator. It indicates overall quality of initial measurements. It suggests the value should be below 10%. And the average actual average is 7.5%. So it indicates that our overall quality of initial measurements is good. DX2 is reconciled correction indicator. It indicates adjustment made by Sigmafine to achieve reconciliation. Its best practice is below 5%. We can see all our values are below it. This is the third indicator, the DX4. DX4 is reconciled difference indicator. It is the measure of distortion between the reconciled and measured flows. Its target value should around zero. Our high values indicate that possible bias in the data and low degree of redundancy. This is our pilot project. The possible next steps are the first steps. For step 1, we can define the scope of the full Sigmafine project. Step 2, extend Sigmafine model and other production areas. Step 3, we should define reports and KPIs based on, we will ask the customer define reports and KPIs based on validated data. And step 4, create corporate dashboardings.